To Pi. Today's derivatives, day 6, and today's topic is derivatives of logarithmic functions. So in my last video, derivatives, day 5, we covered derivatives of general exponential functions. So today we're going to be talking about logarithmic functions. If you guys can recall, in pre-cal 11 or pre-cal 12, you might have probably learned about logarithms. So today we're going to be looking at how to differentiate logs. So let's get started. All right, so the derivative of a general logarithmic function. So basically, if we have just a general log function with a as a base, so this is called the base right here, base. And then a is a base, and then there could be a function here, or just a variable. There's a certain way that we differentiate this according to the differentiation rules. So let me just change my color to blue. All right, and let's get started. So first, let me just erase this so I can write the formula. So when we differentiate logs to general logarithmic functions, the formula that we use is the derivative of log base a x is equal to 1 all over x ln a. All right, and ln is, again, if you recall from my earlier video, it's just the log, the natural log, so the log with base e, and e we discussed in my earlier video, which you guys should check out. Basically, it will result in the slope of a tangent line of exactly 1 at x is equal to 0 for the function y is equal to a to the power of x. I know it sounds confusing, but please check out my earlier video. It'll make more sense. But anyway, that is a formula, and similar to the trigonometric differentiation rules and the exponential rules, you just have to memorize this, and when you keep on doing more problems, you get better and better at it. All right, and that's pretty much it. That is the formula. So let me just put this in a box. So it is important. The best way is just to, again, try to memorize it, try to remember it, and you can do that by doing more practice problems and getting to know the topic better. So let's move on now to the derivative of natural logarithmic function. So just like in our last class, we looked at e to the power of x, and we called this the natural exponent. There's also the natural log, so it's kind of like the log version of this. It's essentially a log, but it's with base e, so it gets a new name, and it's called ln. And it's just represented as ln. But these two mean the same thing. They're equal. So yeah. So now let's just look at the derivative for ln x, because while this rule is applicable to pretty much all general logarithmic functions, the only exception is the natural logarithmic function, i.e. when the base is e. So the derivative of ln x is actually very simple, and it's actually easier than the first one. It's just 1 over x, and that's it. That is the derivative. Again, very easy to remember, and that's pretty much it. So when you want to differentiate ln x, and this again will be a function, the derivative would just be 1 over that function. All right, so now let us just look at some examples that we can work together so we kind of understand this topic better. All right. So we have two questions here, and they want us to differentiate. So for A, we have the function y is equal to ln x4, and the second question is y is equal to log base 2, and then the function in brackets 5 minus 3x, right? So let us start off with a over here, and let me just write it so I can remember. Y is equal to ln x to the power of 4. Y is equal to ln x to the power of 4, right? This is very straightforward. Just like the rule we just learned, the derivative of any ln is just going to be 1 over x, and this whole thing is x. But please remember from our earlier class, chain rule applies in this case, and I'll show you how. So 1 over x to the power of 4. However, this is still a power function. It can still be differential rules still apply to this, and a derivative can still be found from x to the power of 4. So we have to multiply it, and power function rules, the 4 comes down, 4x, and then 4 minus 1 is 3, 4x cubed. Because this is essentially a composite function, it's a function in a function. So the first function is ln, and then we have the power function x to the power of 4. So since we have a composite function, whereas there's multiple functions, we have to find the derivative for each one. That is why we have this. And now let me just simplify this. So what we get is essentially 4x cubed all over x to the power of 4. And this can be further simplified if you remember your exponential rules. This will turn into 1, because if it's a division, it will be a subtraction. So what we have is 4 over x, and that is the answer. So y prime is equal to 4 over x, and that is the answer. All right, so now let's go back and let's answer the second one. Let's go back and answer the second one. The second question is y is equal to log base 2, and then in brackets 5 minus 3x. All right. Let's clear this page because we don't have any room. And now let us just write it down so we remember. B, they want us to find y is equal to log base 2 and 5 minus 3x. 5 minus 3x. There we go. All right. So again, if we can remember the rules that we just talked about, what we can do is y prime is equal to, and then if we remember the rule, it's 1 all over x, which x represents the function, which will be this, right? So let me just write that in brackets, 5 minus 3x. Ln, and then the base is written in front of the ln. The base is 2, so ln 2. But again, please remember there is chain rule because this is a composite function. There's two different functions. Function number 1, not working. Function number 1 is the log right here, and then function number 2 is the 5 minus 3x. So since there's a function inside a function, composite rule applies. So this, what we have solved right now, the 1 all over 5 minus 3x times ln 2, that is only the derivative for the log. So we still need to find the derivative for 5 minus 3x. And to do that, it's very simple because this all applies to our differentiation rules. So we're just going to multiply this, and then the 5, when that is differentiated, that's just 0. Negative 3x, when we take the derivative of that, if we can remember again our power functions, that just turns to negative 3. Right, there we go. And now let us just simplify. Y prime then turns into 1 all over 5 minus, it's kind of hard to write the 3x ln 2 times negative 3, because 0 minus 3 is just negative 3, and this turns into negative 3 all over 5 minus 3x in brackets ln 2, right? And that is your answer. And now some people might look at it and think that this is very long, but this is in fact the answer, and it's totally fine. It cannot be simplified any further. And one tip that I may say is that please remember to keep the ln behind the function. If you put it in front of the function, it can have a different meaning and it can be confused. So please remember to put the function in front of the ln sign. But yeah, that's it for today's video, and this is the answer to question B. And so I just want to make a quick summary. The exponential differentiation rules that we learned in our last video are actually somewhat related to this. It's just now these are logs and those are exponents. So I just have them very quickly here laid out again. So the derivative of log base A x is equal to 1 all over x ln A the derivative of ln x is just very simple. It's equal to 1 over x. And then the derivative of the general exponential function a to the power of x is just equal to a to the power of x times ln a. And then the derivative of e to the power of x is probably the easiest one to remember. It's just equal to e to the power of x. And that's it for today's video. I just wanted to share this with you as well. Please remember, I have a website. Link is in the description. I have extra notes, extra practice problems, and I also have full solutions to those problems with work shown, so you guys can understand how I got the answer. If you have any questions, comments, or concerns, please remember to email me at helpwithmath0@gmail.com. There will be a link in the description for my email as well. Anyway, that's it for today's video. Thank you guys so much for tuning in, and stay tuned as I will be posting more videos in the future. Thank you.